for this nice welcoming speech. So hi, just as Krzysztof said, my name is Adam, and together with Damian, my co-founder, we are happy to create a RealEye platform, which is a platform for doing online neuromarketing research, mostly focused on eye tracking data. So maybe a few words about the history, why we're doing this, basically what is it all about. So myself, by education, I'm an engineer. I've graduated Warsaw University of Technology, a robotics department. And I really enjoy programming, so I was always like coding and doing some crazy experiments. I was also fascinated with the computer vision, but I was also pretty fascinated about user experience and online marketing. So some time ago, when I was doing some coding for an external company, we were asked to make an eye tracking study for the graphical designs that we were creating website for. And so I was partially responsible for ordering this eye tracking research in some external company. And that was around like 12 years ago or 10 years ago. And I remember that I was really shocked about the pricing and about the timing. So the very basic study of doing user experience eye tracking research was almost like several thousands of Polish zlotys. So let's say around like $10K for the entire research based on around like 40 participants. And not only this, we had to wait around 3 or 4 weeks for the results to show. So at the time, like that was okay. I was not financing the project; that was being financed by some other third-party company. So we ordered those researchers. We hired those researchers to do the job, but it somehow stuck in my mind how irrational not irrational, because the value was like we had a lot of value out of the research, but I was really shocked about that there's no other way to gather the eye tracking data and present it faster. So some time ago, several years ago, I started digging into the topic, and I discovered that actually webcams are pretty good sensors, which can be also used as an input data for some other data, not just the video data like I'm talking to you right now. So not just the visual and audio, but also this can be a pretty cool thing to be an input for some more advanced algorithmical things. During my studies, we created a project when we were able to like synchronize the computer with hands, like control the computer with hands and so on. So the thought was pretty instant that this can also be done within the eye tracking area. So after making some proof of concept, we decided to dive in fully into this topic. And thankfully, we had some really nice people around us and companies who are supporting us. We've also developed our software with the help of National Polish Center for Development and CBR. And right now we're happy to be part of of events like this, and be happy to help people around the world speed up the eye tracking analysis and help them out with their daily basis work. So I think I answered the question. By the way, I also wanted to introduce Beata from our team, who will be helping you out with your projects. I'm pretty sure you will get to know her later on, but if you will see the name Beata from RealEye, then that's for sure someone who you can rely on when it comes to our platform. So I think I answered the question why webcams. Obviously, it's faster, it's more affordable, but also it's a cheaper solution. And thanks to the fact that everything is moving online, especially during the pandemic seasons, let's say like this, it's way more convenient to use online panelists, which are already like sitting in front of computers and waiting for people to give them jobs to do, because not only we not only need an eye tracking algorithms, but we also need people on the other side. We don't have our own panelists, but there are plenty of different online panels from all around the world, from Poland, from US, UK, Latin America, and so on, where people are actually getting paid for for accessing your service or your tasks. So we as a company, we are also intermediating with hiring those partner lists. So the time is actually a really significant thing doing webcam-based eye tracking. Of course, there are several more advantages. There are also several more disadvantages of doing this approach. So for the advantages is that participants are actually staying at their home environment, so they're not forced to move themselves to any kind of laboratory, participate in the study, and also there's no need to purchase several things at once. If you want to set up a hardware-based eye tracking laboratory, for sure you're going to need physical hardware eye trackers, which can be pretty expensive. I was at the previous speeches and I saw that you were mentioning Gaze Point from Canada, or eye tracking glasses, or Tobii. So this is the equipment that you obviously need to have, but also you need to purchase a license for the software, and probably some additional softwares if you want to operate on the raw data. But as mentioned, there are several disadvantages as well. You cannot use webcam anywhere. So webcam will not help you out with the research made on glasses, eye tracking glasses. Basically, you can choose webcam if you would like to make research on a screen-based eye tracker. So instead of using a Gaze Point, instead of using a Tobii, you can use webcam, but you have to be aware of several factors. So webcam will give you a lower accuracy, simply because webcam does not operate on the infrared light, so it cannot be. The calculations are not based on the retina itself. The calculations are being made based on the image which is coming from the camera, and the algorithm is usually, there are two types of algorithms that can do the webcam eye tracking. The first one is doing a geometrical calculations to simply calculate the position of head and the eyeballs inside the skull, and the second approach is learning how eyes are looking, how your eyes look like when they're looking at certain parts of the screen. So we're using the second approach. We think it's a bit more convenient and faster to get the results. But basically, you can expect a lower accuracy than on the hardware. By saying this, we like to call it like, with the hardware eye tracker, you can have a letter size precision, letter size accuracy. Within a webcam, you can expect a button size accuracy. So if you're in charge of creating the stimuli for a webcam eye tracking study, you should be aware that your stimuli should be created in a way to separate elements on the stimuli itself by the size of kind of like an internet button. So let's say around like 5-6% of the screen width and height. Another disadvantages, webcam won't give you any information about pupillometry. So I don't know if this was already mentioned in the previous lectures, but basically pupillometry is a methodology that gives information about the size of retina inside the eye, and the size of retina can change when interacting with a stimuli. I'm pretty sure someone will cover it in more scientific way. Just from the bird view, it looks like this. So if you are experiencing for instance, a fraction using a user interface, your retina size might also change the size, but that's as mentioned, the bird overview. So you won't be able to do it with webcam. And another thing is that the maximum frequency rate we can do calculations on using webcams is up to 60 Hertz, because typical cameras are between 30 to 60 frames per second, usually the first one. So usually we get the data within the frame rate of 30 Hertz. But a positive side of it is that it's perfectly enough to make calculations for fixations, because fixations last like around 100 milliseconds, and within 30 Hertz, we can have the fixations with the minimum length of around 30 milliseconds, according to the calculations that we made. So this is okay. This is all right. Okay. One last disadvantage: webcam eye tracking is kind of a new thing. So the software maturity is not at the same level as it is in the hardware eye tracking providers with their software based on licenses. So by saying this, if you're using, for instance, Tobii Pro software, then you may expect that you'll have lots of different functionalities than using an online webcam eye tracking provider. But obviously, this is going to change in time, and this is changing over time. So you can actually compare this if you had a chance to do some video editing. There are tools like Adobe Premiere Pro, which is like a very professional tool where you can do anything, like anything literally you want. And in case you're interested in just merging videos or doing some small effects, adding music and so on, you don't have to go to the full Adobe Premiere toolbox, which is pretty expensive. You can use plenty of different movie makers which are available online or offline. So maybe that's a comparison. Okay, so that was the introduction side. I've also prepared a small task for all of you before we move into another part. But before we do the task, I will also like to tell you a bit more about our tool, about RealEye. But on the technical level. So what can you expect from running eye tracking studies on online platform, just as RealEye is? So you can expect, first of all, you can expect very similar type of results as you were running an fully locally based eye tracking study with a screen-based eye tracker. So you can expect individual results for each participant. For each of the participants, you can expect eye tracking gaze recording, so the gaze estimation in time over stimuli. You can create tests on images, on videos, or even on live websites. But with the note that you cannot aggregate the data on live websites because simply because the flow of each participant is going to be different on a live website. And let's say that you're starting from some page and one participant is navigating to Facebook, or another person is navigating to some other link, then the aggregation won't make any sense. But basically, you can do single participants recording over live websites and do the calculation as well. There's also information about the data quality for each participant. So this is pretty useful because you should expect to have some offset when it comes to webcam-based eye tracking. But as far as I know, the offset is also a pretty known thing when you're doing an offline in-house laboratory studies. So when I say offset, I mean that some of the participants may not be able to calibrate well, or the data quality won't be good enough to make use of it. For instance, webcam frequency rate can go lower to, let's say, 10 hertz due to some unknown reasons. Maybe the computer PCU was, I don't know, too hot, or the web browser was stuck with too many tabs, which is happening a lot. So you should expect that not 100% of your participants will be able to finish the study, but out of the rest 80%, you will be able to get pretty good quality data. One thing, just as a note, I think it's important to know that especially nowadays, when we are really concerned about, when the world actually is really concerned about the user data privacy, and when we are in the neuromarketing field, there's even more, the privacy is even more concerned, because we are actually studying this is a behavioral research, so we are actually not giving our respondents even the ability to choose their reaction. We are just recording their reactions. So we don't record any videos of them, and we are fully anonymizing the data. So in case you'll be using our platform for your research, then you can be perfectly sure, perfectly fine that nothing is going to be stored and anything is going to be anonymized. Actually, there's even something called NMSBA Code of Ethics. When the neuromarketing field is actually developing pretty fast, there's a code of ethics for doing a neuromarketing research. And some of the statements are saying that someone who is being studied in a typical neuromarketing research, the person who is being studied should be fully aware of that he or she is being a part of neuromarketing research and so on. So that's also a pretty good practice to inform participants before inviting them to the study that this is going to be an eye tracking study when we will record your behavioral like your eye movements and so on and so on. But please don't be worried, the data is like protected and safe. So this is kind of like a nice thing to do before running an eye tracking research. Okay, so a few more things about the platform. So what else you can expect out of the results? So you can expect that you will have not only the recordings for each participant individually, but also the aggregated data for all the participants from your study. So let's say that you're doing an image-based study, and the image is, I don't like a shelf of on the store, or like an image or like a poster for some online advertisement, and you're inviting 50 participants. So you will have information about how any one of them were interacting with the image, but also an aggregated information of averages. So average time to first notice, average time to first fixation, average time spent, and so on chosen fragments of the image. I'm going to show it to you later on. Not so, as mentioned at the very beginning, we are mostly based on eye tracking data, but since we already have people sitting in front of computer doing our tests or tests for our customers, then we are trying to get as much information as possible, which can also help with the research. So we are also storing the information about mouse position, mouse cursor. We are also storing clicks. There is also ability to run a short survey, which is kind of like the declarative part of the eye tracking study. And there's also option to do the facial coding analysis, but I'm not going to talk a lot about it. Okay. I don't know, Krzysztof, you wanted to say something, or that was just my... Okay. I thought that you were interacting with me somehow. Okay, so moving on. I know that in the previous session you were talking about gazes, you were talking about fixations. So these are also the metrics that we provide. So the difference is like pretty obvious, but just to make it clear, gazes are all the points that are being captured by the eye tracker, and the fixations are kind of like the points which are being calculated over the cloud of the data, over like a mesh of the data. So fixations are kind of like, we like to call like a small magnets, which are being placed in the middle of gazes. So in case there's a lot of gazes in this place, a fixation is a one point which represents the set of gazes. And there are some conditions which are saying if fixation actually happened in this particular place or not. But it's going to be covered later on. Okay, so moving to the practical side, I've created a very quick demo study for you, and I would like you to participate in this. So as mentioned, you don't have to be worried. There's nothing being recorded on the webcams or anything like this. So I'm just going to share you a link here on the chat. And if someone would like to participate, it's not obligatory. Like you can choose to participate or not, just like in any other neuromarketing research. So to participate, you will need a laptop. If you're on a mobile phone or tablet, then you can either switch to a laptop or a desktop device to participate. If not, then you'll have to just wait like 5 minutes for others to participate. So let me share a link with you on the chat. Just give me a second. I need to start the study. I'm not showing you how to create the study for a reason, because I don't want you to see the images that I've created for the study. I want you to see them for the first time, so interaction is natural. Okay, so there it is. Let's meet here in 5 minutes. So see you later. Okay. I think that most of us already did the job. I have 45 results collected, and for the past like 30 seconds, there was no new result. So I assume that that anyone who wanted to, who had the capability to participate, finished the test. I can see that on the comments, some of you had failed, like Krzysztof is writing that his attempt to launch the study, that something was wrong with the Chrome web browser. And this is exactly what I was talking about when I was mentioning the offset. So sometimes it's because of some ad blocks, sometimes because of some browser extensions, auto full screen options. And
Adam, if
yep.
I think because I had also a problem, but I know why, and I solved it. It's because Krzyś is still having his camera on used by Zoom. That is why RealEye could not take over the camera. So Krzyś, it was a problem with me, but once I switched,
it was my problem.
I'm sure it was.
Yeah, but actually, it sometimes happens that people are doing eye tracking research, maintaining eye tracking study test, maintaining the communication on the Zoom or any other tool, and we are advising them to kill the camera on the communicator first before running the test, unless the webcam is used in the browser, in the same browser as our tool, because then the access to the webcam is shared between several different applications. But these are the things that are causing the offset, and that's something that we're constantly fighting with. But anyway, I think that was pretty great. I can see that 3 more people participated, so we have 48 participants, and we've collected the data within 7 minutes. So this is pretty powerful when you think about it, that we've gathered 50 probably. Oh, actually, I'm wondering what's the quality of the data, but I'm going to show it to you in a second. But the fact that we've been able to do it within just several minutes is the thing that it's really fascinating for us, and we're really proud of it, that we can speed up the eye tracking research this way, and hopefully that the results will show some good quality data as well. So what I would like to do now is to show you, share my screen and show you how it looks from my perspective. So how I've actually created the study, and how it looks from my perspective. I believe you should be able to see my screen already. Okay, I can see that Isa is showing me yes, so perfect. I'll just move it to another screen. So from the perspective of the researcher, this is how it looks. So this is my dashboard when I can create several different types of study. So let me create a study just like you were participating in, by simply selecting an images type study. A few words, because I believe you're also going to use the platform for your own researchers. So all of you should be already registered on the platform. We got the list of all the emails. I saw that Krzysztof sent me the updated list. If not, then please feel free to sign up today after the classes, or meanwhile, that's perfectly fine. We're going to update the licenses using the list that Krzysztof provided us with. So in case you would like to choose that your study is going to be image-based, you have several things to know. You should know several things: that you can display up to 100 images in a row, and the maximum study time will be limited to 10 minutes for the license that you got. If it's not enough, then Krzysztof, let me know. If someone will say, Krzysztof or Isa or someone, please, we can extend the time. But as far as I know, that 10 minutes is perfectly fine for doing studies like this. I can see there is a question. It's possible to present games in HTML5 or JavaScript code directly in RealEye. It's not possible to do it directly. It's possible to do it by the live website type of stimuli. So if you choose, maybe let's start with this one. So if we choose a live website type of study, all we need to do is to paste the website that we would like to make the test on. There's also an option to enable voiceover or not. So let's say that we want to test lead me event page. So what we have to do is to paste the lead me URL and set the maximum threshold for the study time. So let's say maximum session will be limited to 3 minutes. And there's no need to paste any code or anything like this on the tested website, because the entire test is going to be kind of like the screen session recorded. So just like I'm sharing the screen to you, you will get very similar outcome of a screen sharing session with the gaze prediction on it. So this is if I would like to choose, if I like to run the website eye tracking study, that's everything I need to do. But let me go back and create the images-based study. So you'll see how to create a study, that the one that you've just participated in. For the ones that didn't get a chance to participate, because maybe a few words about it. So that was a study made from, I think, 4 different images. Some of them were clickable. So there was a need to find and click an element. 2 of them were just thresholded to 5 seconds. And there was a short survey being displayed in between those elements. So let's create a study like this. Let's say that we will show items in random order. We are going to show separator between items. The separator is a little cross in the middle of the screen. So we had a discussion actually about this cross, that it should be presented in the random place on the screen. But right now it's being presented in the middle, but there's an option to disable it or enable it. It's made mostly to simply bring the attention of the participant to the center location of the screen. And there is also a solution for it, doing the analysis to get rid of this fixation bias by simply starting the analysis after like 200 or 300 milliseconds. This is something that is questionable, but this is something that every researcher is handling on his or her own. Another thing, which may be actually pretty important in your case, is ability to attach external tools, external integration. And this allows you to redirect participants to some other URL after they finish the test. So imagine that, for instance, you're doing an images-based study, and afterwards you want them to go further and do some online survey, or maybe you actually want to connect with them via Zoom meeting. So here can be any kind of URL when they will be forwarded after the test. The other URLs you can input are URLs that panel providers are using to simply control the amount of participants. I think they're not that relevant as the finished URL, at least for our purpose. Next thing is an optional intro message and optional message after the test. So please return to main survey, please close the tab, and so on. In this case, let's just say, please enjoy the eye tracking study. And click next. So the next step is ability to upload the stimuli. So since we are using images-based, our study is images-based, and we're going to add 1, 2, 3 different images. After, there was supposed to be 4. I don't know where the 4th one is. So let's just add those 3. Actually, maybe I'll be able to. Yeah, there it is. Okay. So the 4th stimuli was a screenshot of a website. So it could be a website, but we wouldn't be able to get the aggregated data. So that's why I chose to present it as a screenshot, as an image, so we can see the aggregated data. So for each of the elements, there are several options. So for instance, before presenting each of the elements, you can type a line of instruction. So for instance, click the product you would purchase. And there's an option to add the additional short survey. So for instance, we can ask, have you found the drink you usually purchase. This can be a yes, no question. We can randomize the answers and require the answer as setting minimum 1 and maximum 1 choices. And we can add another question about like text answer. What do you usually drink? And it's not required, so let's say that 0 is the minimum length. So this stimuli is almost ready. We can also add the ability to finish on click, which is actually enabled in the test study. So it means that if someone clicks in this area, which I'm selecting, the displaying of this element will finish and the test will continue. So what I did, I actually selected entire image because anyway, all the clicks are being stored. So I just wanted the effect that if anyone clicks anywhere, then the test will move on. Also, there's an option to finish on key press. This is pretty useful if you want people to decide quickly. So there's a test called implicit associations, implicit reaction tests. These tests are very often used to discover some biases or maybe like implicit thoughts and associations. And it says that participants should lay their fingers on, for instance, arrows on the keyboard or on letters A and L. And as soon as they decide whether the right side or the left side is their choice, they should click it as soon as possible. And I will show you results of this test later on. I'll just take a note for myself. Implicit reaction test. So I'll show it to you. But we're not going to turn this on. So another 2 advertisements, let's say 5 seconds, each of them, no survey. This image had actually a task, which was click the LinkedIn button or something like this. And the display time was limited to, I don't know, 20 seconds. That's perfectly fine. And the finish on click was made on the LinkedIn. So having prepared a study like this, next step is hit a preview, and the preview will allow you to participate in the study just as participant will do. There's an option to launch a quick preview, and actually I'm going to do it. I know that some of you already seen this test, but for those who haven't seen how the calibration looks like because they were not participating, I think we should give them a chance to try. Oh yeah, my webcam is being taken by Zoom, so I will restart the test. So I've selected a quick preview, so I will just calibrate using, I think, 5 dots. So my results won't be really accurate, but you will see how the flow of the study goes. So in case it's a full calibration, there's 40 dots like this. And the test starts, so please enjoy the tracking study. One thing I'm going to show you when the first stimuli is going to be presented. So if I move away my face from the screen, which may happen, RealEye is trying to make sure that the eyes are in this similar position as they were at the very beginning. So when you're running a webcam eye tracking studies, it's actually important for participants not to move their head too much. But obviously, like some small movements are perfectly fine, and you cannot just sit tight. But in case you're moving, so participants are moving too far away, then this pop-up is showing up, and it's also lowering the quality of the ended data. I'll show you in a second. Okay, so right now the the test is still happening. So this is how it looks. This is something that I did wrong. This is scrollable. When I would like to run this test on production, I wouldn't like it to have a scroll bar. So this is why I'm running a preview to make it, to simply be able to correct it. So this is being displayed for 5 seconds. There is a short survey at the end of the test. And if you're running a preview, you'll be able to actually to see your results instantly. So this is the gaze recording of myself doing the test and some heat maps. I'm not going to play it right now because I was doing the quick calibration with 5 dots, so I wouldn't expect good results. One thing that we need to fix is that this planogram, it had this scroll bar, which was not natural. So there is this option scrolling, and I want to turn it off. The scrolling feature is pretty useful when we're doing a test on a longer stims like a website, when we actually want participants to feel like they're on the real website, so they can use the scroll. Okay, so I can run another preview, but obviously I'm not going to do it. Next step is to select among the participants. So this is simply setting up the limits. So for instance, I want the study to be filled with maximum 50 of my own participants. So in case I'm inviting the 51st participant won't be able to join. And there's an option to hire our panelists. And by saying our panelists, I mean that we are contacting semi-automatically with some other panel providers, and we can bring you the results within 24 hours. But I assume that having so many, such a big collaboration here with the group of almost 90 people, then I believe that we can participate in each other's studies during the workshops. Okay, so that's the dashboard of a running study. So we can see here on the left participants and items. Items allow us to do the quantitative analysis because we can see survey results, which are obviously empty right now. We can do the aggregated analysis. And on the participants tab, we will be able to see all the participants who participated. So let me now jump to the study that you've been participating. I see that there were totally 53 participants in the study that I've sent it out to you. So this is really great. I think that the sample of having a 50 results is perfect. So before jumping into results, let's see how it looks. So for each participant, we have several information. So for instance, we had Irina and system graded the data quality as low. We can see the details, why it happened, and we can see the flow. So there was a calibration, then there was a study instruction, first stimuli, second stimuli, line of information, stim, survey. We can see the survey. So have you been on the website before? No. And the website was graded for 4 stars. Then there was another stim, and then there was the test was finished. We can also tag the participants. So we can say that, for instance, I don't know, orange, and the other one will be blue, and the other one will be also orange. I'll show it to you later on. The orange. This can be used later on for filtering the results on the aggregated dashboards. Okay, so let's go lower. So we have another one, data quality, very good, data quality, very good, good, very good, very good. I can see that data quality is really good for this study. Can I push tags via invitation URL? This is a good question on the chat. You can push things called additional parameters, but they won't become tags. So they will also be stored within each of the participants' results. So we can accomplish it by simply adding some additional variables here in the URL. So for instance, name Adam and gender equals 1 is male in our system, and some key equals some variable. So these things will be stored right next to each of the participants, but this is something pretty actually useful when you're using some other external panels. Okay, so I would like to see now how in general the data quality looks like. So we have this button here, quality stats and drop rate, which is going to show me how in general the study looks like. I haven't seen it for this study yet, so let's see. So the average eye tracking data grade is very good, which is very good. Average click versus gaze accuracy is 77%. Okay, I know what I did. Just give me please. I wanted to show you actually another how we are calculating the grade, how we are grading the participants, but I don't have it linked. I don't have the link here. So the click versus gaze accuracy, it's good if you're running some test study when you're saying click where you look and so on. In this case, I would rather ignore this because there was no such instruction. We can see the drop rate. So we can see that the test link was opened by 85 participants. 57 of them have granted webcam access. So this is the biggest offset we see here. Maybe some of the participants were visiting it by a mobile device or something like this. The offset from 57 to finished test, which we have 53 results, is a very small, it's a very nice offset. Just 5% of people who granted the access couldn't complete the test. As mentioned, it may happen, but it seems it was very good. And we can see all the participants with all the statistics here. And as mentioned, these results look really promising. One thing I wanted to show you, because I'm talking a lot about the quality. What does it mean that it's very good? What does it mean that it's low? So just wanted to briefly show you what does it mean and when you can use and when you can't use the type of data and the type of part, like the kind of the quality. So we have 6 different steps: perfect, very good, good, average, low, very low. And for the participant to qualify as perfect, the average, the eye tracking sampling rate should be above or equal 30 Hertz. It means that our system can compute fixations, and over 90% of the items should have the data. So in case you have, for instance, 100 images, then we have a data for at least 9 out of 10, like 90 out of 100. The total eye tracking data length is 99%. So it means that someone was not moving away from the computer or moving the screen, the eye behind the computer. And the gaze on the screen was for 99%. So this means that the eye were on the monitor for 99% of the time at least. So the threshold is actually here between the good and the average, because the average results won't give you the ability to calculate the fixations because the frequency rate is too low to detect the fixation duration, and everything above average is perfectly fine to do the fixation-based analysis. If you're thinking about doing gazes-based analysis, which is very often used with more psychological research, because it's simply storing all the gaze points that everyone was leaving, then you can also use the average type of data. Obviously, we wouldn't recommend using low, which are under 1 Hertz, or very low, which is like no data at all. So let's see why one of our participants got low data quality. We can see what I did. I just clicked the see details button here to see this particular participant and what happened. So we can see that the eye tracking data was for all the items. Eye tracking data was for 63% of the time. Gaze was at the screen for 19% of the time, and the sampling rate was 21 Hertz. So it seems pretty good. It's because 63% of the time we have the eye tracking data for, so something might happen during the test. I would rather keep the data like this. It doesn't seem really bad. Just one thing, we can ignore the participants if we think that it's below our expectations. We can simply click ignore. This is actually myself because I also did the test, so I can click ignore and my results won't be calculated into the end results. Okay, so maybe let's see the results, because I'm talking and I'm not showing anything exciting. So let's start by analyzing the results on the aggregated way. So there was a survey here on this item. So let's see the results of the survey. Have you been on this website before? Yes, 40%. No, 60%. 60%. Okay, and majority of you decided that this website looks as a 4-star grading. I'm surprised that not all of you have been on this website, because this is the main website of this event. So that's not really good, but well, this is anonymous, so we won't find out who was there and who wasn't, thankfully. Okay, so that was the result of the survey. Now we can go and see the heat maps. Let's start maybe with the website. And maybe before even going to the aggregated things, let's see at the single participant what we can see. So first of all, we can see the recording of the gaze and also a fixation plot. So this is a single participant result. The orange dot is the gaze prediction, and the yellow dots are the fixation plot. So these are all the fixation calculated based on the gaze data. There are several options. We can also show gaze plot right away next to the fixation plot as well, so we can see how the eyes were moving on this image. Okay, someone clicked the LinkedIn sign. There was actually a click visible. Okay, so as we are looking at the recordings, maybe this is a nice moment to say a little bit more about the fixation filters based on single participant results. So here there's an option to show or hide advanced settings. And let's first focus on the first factor, which is a noise reduction. So imagine, right now I'm just going to talk a bit about the data processing, which is happening behind it. So the noise reduction filter, the noise reduction is simply making the data not that noisy as it may sound. So the first 2 seconds within the noise reduction filter of 21 frames look just like this. It's a bit of kind of like square, like pretty linear. Let's say that I will reduce the noise reduction filter to 1 frame. And what you can expect is that the gaze, so the dot, is going to jump like crazy because the data is not being denoised at any moment. So it's just shaking. So the denoise algorithm, the noise reduction algorithm, which is actually a moving median algorithm, if anyone is interested about it, is telling us how many frames, one after another, we would like to take and make a median out of it to denoise the algorithm. So we recommend setting around between 11 to 21 frames, but this is purely from our experience. So this is the gaze plot. So another thing is the fixation plot. I'm just going to hide the gaze plot right now. And the fixation plot is being painted based on the fixations that our fixation algorithm has calculated. So first, let me just go back one step and see, based on this participant, the data chart. This is pretty advanced usage, but it's pretty logical way to show you how the fixations are being calculated. So this graph is showing you the eye movement, the prediction of the gaze point in time. So here is the time from 0 to 5,000 milliseconds. And here from 0 to 1,200 is the pixel, are the pixels of the screen. So this is the y dimension, and this is the x dimension of the prediction. So imagine that if the y and the x are not moving, it means that the gaze is being placed at the one place because the eye is steady looking at some place, and at the same time this Turkish color velocity, which represents velocity, is steady because the eye is not moving. So this is the speed of the eye. So whenever there is some movement on any vertical, y or x, the speed of an eye is increasing. So let's see here, for instance, the x on the x-axis, the speed of the eye was increasing because I was jumping from around 500 pixels to around 800 something pixels. So the eye was gaining velocity. So it's also represented on the graph. So based on those 3 factors, actually 2 factors, velocity of the eye, speed of the eye, we can calculate fixations, because as long as the eye is not moving away for faster than some desired threshold, we can say that there might be a fixation. But there's another thing that will take into account whether the fixation was happening or not, and it means the minimal fixation duration. So let's look at here, for instance, the velocity, the I velocity was at the 0, and the X and the Y were pretty steady, and there was no fixation. The fixation are, by the way, the blue squares. So for instance, here the fixation was being recorded, here, 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 and there was no fixation here because our algorithm was set that the fixation means that the eye has to be at one place for at least 100 milliseconds. Those variables can be modified. So probably if I say that the minimum fixation duration for me is 80 milliseconds, look what happened. The fixation was actually added here. So we did some learning how other hardware eye trackers are doing the filtering, and very often they're setting up the minimal fixation duration for around 130 milliseconds, and the gaze velocity threshold is the parameter which represents how fast the eye has to move. So there are two fixations. For instance, here there are two fixations because I moved within this threshold faster than 10% pixels of the screen in a second. I would rather leave this as is. Okay, so this is what the fixations are. So I think we can go back and move to the single participant recording. I will remove the gaze point. So what we're seeing right now are the fixations one by one within those filters. So let's reduce this filter to 80 milliseconds, and we should probably see some more fixations. I don't know, actually it's hard to compare, but we can see that these are the fixations happening one after another. And there are some moments where there are not even when there are no fixations at all. To get more fixations, we can also operate on the noise reduction filter because it's going to denoise the data. So for fixation calculation, we recommend having a filter set to 21 frames, which is default on the heat maps. So this is something that we're usually doing and recommending for the fixation filter parameters. Okay, so these are all results for single participant. There are also some facial coding analysis I mentioned before. I'm not going to focus on it, but we do provide two different verticals, happiness level and surprise level. These are simply being measured by looking at the muscles on the face, which are being responsible for moving mouth as a happy, and mouth and then eyebrows for surprise. This is based on FACS. This is a facial action coding system invented by Paul Ekman in the 1980s. So this is purely putting the math behind the face mesh, behind the face mask into some graphs. Okay, so since we already know how to operate on this data, let's see again how it looks. So we have now all the layers. We have also the layer of mouse movements. As you can see, the mouse cursor is moving. And actually, based on a recording like this, you can get a lot of conclusions if you're doing an eye tracking session or eye tracking research like this. But that's just a single participant's recording. So we can now officially move to another type of visualizations, which are heat maps based on aggregated data. And this is it. So this is a heat map which was created based on 23 results from all the panelists. I accidentally clicked just one of them, so let me go back. So there was this small survey at the end of the eye tracking test, which allowed us to collect data about gender, age, and age. So we can also do the filtering here and the tags. So for instance, we only want to see participants with tag orange, and we'll probably see a heat map from 2 out of 53 participants, which is quite right. So let's go back to all the participants because that's what interests us the most. Let's cut off people with low result. So let's just leave people from average to perfect. And we can now do the analysis. So what interests us the most in here is probably the LinkedIn button. So we can set an area to see how many of you have actually seen it. So when setting an area of interest, we recommend setting an area of interest of around like 5-7% of the image width. As you can see right now, I did it a bit bigger than just the LinkedIn sign. I could do it this way, but since it's a webcam eye tracking, not and it's button size precision, not a letter size precision, I would rather create a bigger area of interest and include it somehow in my error. But probably that's something that would work. So we can save this area of interest as a button and see the calculations. So there were 24 clicks in this LinkedIn button. Average time to first fixation was 10 seconds, and average time spent was just 0.58 seconds. There were in total 35 fixations, and 12 out of 51 participants who left any fixation fixated here. So I'll go back to it in a second because we're doing the fixation-based analysis. So there were 24 clicks. Average time to first click was after 8 seconds. So you can imagine that after 8.72 seconds, people are actually discovering this button and clicking on it. But these are all, we can see that there were some clicks in here. For instance, there was a click. I can customize the heat map to see only, for instance, clicks. Someone was clicking here, here, and so on. We can also see mouse movements, but that's not really relevant at this moment. So, okay, let's go back to the heat map view. So we can see these calculations were made only on fixation-based analysis. We can also do the analysis based on gazes. And as mentioned, the difference between gazes and fixations earlier, fixations are only the points which are being calculated by all the filters that I've presented to you previously. So based on gazes, we can also see some other statistics. So for instance, average time to first gaze was around 9 seconds. Average time spent was around 0.66. There were total around 800 gazes, and 33% out of 51 actually gazed in this area. Okay, so since we have it like this, we can also set the time thresholds. So for instance, see what our testers were paying attention within, for instance, first 2 seconds. Okay, and do the same type of calculations as I did previously. So we can see, for instance, how many of you noticed the logo, how many of you noticed the YouTube sign, and so on and so on. We can also play the heat map to see the bug swarm. I don't know how it's called, but it's basically kind of like the moving heat map. Okay, moving on. There's an option to download this data and do the further analysis in Excel or in any kind of different solution. You can also do some programming in Python as you wish. But maybe let's go and jump to see some other results. For instance, the ones with John, no, it's not John, with Brad Pitt. Actually, I did it on purpose because there is this story, that this fact, myth, I don't know how to say it, that people are looking at the product more, they're paying much more attention to the product when the actor on the billboard is looking at the product as well, and not in the eye. So there is even this graphics. Sorry, let me just. No. I don't want to shop. Oh, so this is the eye tracking myth, and I never know if it's fact or not. But basically, when this kid is looking at the advertisement, at the product, more attention goes to the text. And when this baby is looking directly at you, then more attention is going to the baby face. So Let's see if we had the same situation with our Brad Pitt looking at us directly versus Brad Pitt looking at the product. And let's kill the myth. Let's do some mythbusters. What I wanted to do now is to fit it to the screen so it's more visible. So we can see that for both of the ads, of course, there are some different circumstances on both ads because the channel number 5 bottle is bigger and smaller on the other two. So that's not the test that it's going to actually confirm or deny the hypothesis, but let's just do it as for fun. So let's say, so Brad Pitt looking at us is average time spent. Let's do amount of fixations. So for instance, it was 280 fixations versus Brad Pitt looking at the product. It got 218 fixations. So it got much less amount of fixations. Let's also compare the product itself. I'm just doing it very roughly without keeping, the area of interest very accurate. But so when Brad Pitt is looking at us, the product gets 280 fixations. So it's kind of like 50-50 of 50% of attention went to the Brad Pitt's face and 50% went to the product. And in this case, we have 345 fixations on the product and way lower at the Brad Pitt. So myth confirmed. Okay, that's a very, very, very cool example. Actually, I would like to repeat it, only having like the first, let's say first 2 seconds, if you don't mind. I think we have time to play a bit more with those results since we actually gathered them in a proper way. So within the first 2 seconds, there is 100 fixations on the bottle versus 141, so way more on Brad Pitt. And here 140, yeah, same thing. So pretty cool. Okay, moving forward, this is our last stim, which we were testing. So this is planogram, and this is actually, as a company, we cooperate with 2 different types of customers. The first one is the first type of a customer is are universities and research centers and so on. This is actually the ones that we prefer to work with because they are kind of like challenging us to to increase the quality of the tool, and we have very nice communications with them. And the other half, let's say, is a neuromarketing agencies, and they are very often doing commercial projects. So they are not as experienced in eye tracking. They're just trying to utilize the data. Very often they don't know how to do it. So we don't learn much from them, to be honest. But this is a typical planogram, and this is a test that they are very often doing for their research purposes. Of course, it's not just a matter of planogram. This is just a part of the study. So imagine if they are, for instance, choosing a new logotype for Coca-Cola Zero, which is right now very popular in Poland. That would be just a part of study. It would be just an ingredient to make the end decision. Probably they had lots of quantitative and qualitative sessions, surveys, reactions, and so on. Of course, it's not an official study. It's just my draft. But basically, this is also helping them out to choose if the product is visible or not visible among others on the virtual shelf. And the planograms actually look very similar to this one. So what I'm doing right now, I'm looking at the clicks. So I want to find out which one got the most amount of clicks. So Coca-Cola got 8, Coke Zero got, it is here, also 8, 7-Up nothing, Fanta 2, and I think this juice got also 8, Lipton 9. So probably Lipton would be a winner when it comes to clicking, but we can also do some analysis when it comes to eye tracking data based on the heat maps, and we can see all the data that we were interested in previously. So we can see what's the average time, for instance, to first fixation. So in case brands are doing an A/B test between two Lipton new envelopes, they are placing the different bottles in the same planogram. So imagine they would place a very similar planogram. Everything except this part would be the same, but there would be another Lipton brand, another Lipton envelope over here, and probably the same test would require to have the Lipton bottles right over here, and so on, to make sure that the results are actual. So in this case, even though it got the most clicks, it was probably not the first to see. It got the average time to first fixation is around almost 3 seconds. So this one is also almost 3 seconds. This one is 3 seconds. Okay, maybe I'm doing the analysis from 0.5, not from the very beginning. This is weird. Average time. Okay, maybe I should go and do the analysis on gazes, because this is the first site. Average time to first gaze, 2 seconds. I'm just wondering if, yeah, the middle of the screen obviously has it the fastest. So after 600 milliseconds, there's an average gaze. So people are simply browsing. Okay, I'll go back to fixation then. So as you can imagine, we can get a lot of outcome of it. So to do the proper analysis of a planogram like this, researchers would probably need to make areas of interest for each of the set of the barrels, and then export the data and do the further comparison analysis based on the for instance, fixation. CSV is pretty, no, actually it's not a good one here. We can probably go and check the areas of interest overall stats file, which will compare the numbers for each area of interest that we've selected. Let's see how the file looks like, just to, I need to import it in another way. This is a typical CSV file divided with the semicolons. Okay, so since we had 2 areas of interest created here, Lipton, Dr. Pepper, we can see 2 different data sources here. This is for Dr. Pepper. I'll zoom in a little bit, and we have all the numeric data that we had here. So our fixation average time to first fixation in milliseconds. So this is ideal for comparison. We can see that this was being noticed faster. Average total time spent. So that's actually pretty big difference, and so on and so on. So all the numbers that are visible here on the areas of interest tool will be downloaded into XLS file, which is way more convenient to the comparison analysis. Okay, I can see that there are 2 questions, so maybe let me try to answer them. Oh, I can see that Beata jumped in. Hey, Beata. Okay, Adam, how do you define gazes and fixation? What is the difference between these 2? I think I already, okay, this is from Krzysztof, so I probably missed something. So basically the difference between the fixations and the gazes is that the gazes are all the data points that our eye tracker captured. So let me visualize gazes. Yeah, that's actually a good idea. I'm just going to visualize gazes and fixations on one of the images with a good data quality. So you will see. Let's go to gazes first. This is a heat map, and heat map is nothing else but just a colorized version of circles, and each circle represents a gaze point. I'm just going to make it very clear. So these are all the points that our eye tracker captured in time, starting from 0 to 5th second. As mentioned, they are after denoising function. So if you want to see the rawest type of data that our eye tracker captured, you have to hide the noise reduction to set noise reduction to 0. So this is the rawest type of data that our eye tracker captured. These are all the points, and we have, since it's 5 second data and we're capturing 30 frames per second, we should have around 5 times 30 dots here, which should, so we can actually check it. So it's 327 dots in here. When we go to fixations are also kind of like dots which are being displayed on the screen, and we can also like maneuver those points to look differently, even to look like this, because it's just all the matter of points, but they are being calculated based on all the gazes. So if we had a cloud of gazes here, there were a lot of different points here, we will just have one fixation, which is representing the all these dots, and it has a time, so we know how much time this fixation lasted. So that's the idea behind the fixation cases. Hopefully that's that's the best way I can. That's good enough that I can explain it. Okay, moving on to another questions. Second question, I'm not 100% clear on what the difference between gaze and fixations in RealEye. Also, do the circles representing the fixation always have the same size? Yes, they differ in color if the fixation is longer. In some eye tracking systems, they can give an idea of fixation duration. Shorter fixations, smaller circles, which can be quite useful. And this is exactly what's happening when we're looking at the individual recordings. This is kind of like a new feature in our platform. So here, if we have this fixation plot, then actually longer fixation means bigger circle. Take a look. If we show gaze plot and fixation plot, then the gazes are all the same size dots, and the fixations are bigger dots. Actually, this is also a nice way to show the difference between the fixations and the gaze points. So out of plenty of gaze points, we have one big fixation. Okay. And here's the answer of Beata, as always, ready to help. Actually, yeah, that's a pretty cool article in our support section, which describes how it works, how it looks. So it would be great if someone is still not aware of the difference, then please go ahead and see the article. I don't think that's the concept. What's the utility of looking at the raw data points? Yeah, there can be quite a big noise. That's why we're doing the denoising of the data. But from our experience, as we were looking at some other use cases, very often researchers, especially cognitive psychologists, were more interested in gazes rather than fixations. Hard for me to tell you why, but that's something that we've observed, that they're very often doing the calculations or raw gazes. Obviously, they are the gazes are kind of like faster, recording all the reactions, and they can let's see here. Even though the gaze point was here on the left, there was no fixation, you can see. So for psychological research, this may be pretty important, that the gaze actually moved back and forward. Meanwhile, the current settings for fixation filter haven't recorded it as a fixation. For sure, we can maneuver the fixation filter, for instance, to detect fixations if the fixation minimal length is, for instance, 60 milliseconds. And you can see it, actually this moment was captured as a fixation. So the fixation filter is something that we leave to researchers to decide. By default, we set up it at 100 milliseconds I'll be actually happy to learn more from the community, how they are seeing the difference as well. Okay, I can see that Beata was answering the question. Is it possible to set dynamic area of interest in the video on RealEye? Unfortunately, no. Unfortunately, video-based analysis requires also making a static areas of interest. And it's, well, from my experience, it's not the easiest way to analyze the videos, especially when the videos are really fast and like changing rapidly. But in case the video is kind of like semi-static, and for instance, the brand or the logotype is visible for some longer time, then yeah, then it's perfectly fine. Let me just jump to one of the sample studies made on videos in October 2020. That's a Heineken campaign. This is our internal study, just to show the capabilities. So very often, for instance, these heat maps, these analyses were made on areas of interest which are static, but areas of interest are also depend on time. So if you create an area of interest just for some selected amount of time, then when you export the data or the analysis in the dashboard, then they will only count the moments of when the area of interest was created. So for instance, here on the video, there is, for instance, a moment when they are showing a Heineken brand or something like this. So we can create an area of interest and just attach it to this chosen amount of time. This is something that it's not the most convenient at the moment. I have to admit that. Okay, I think the questions are over. Also, to be honest, it took me a bit faster than I expected to to make the experiment. So I think I will now just a second. Yeah, I'll now leave some space for question and answers. So if you have any questions and or maybe you'd like to see more, then that's a great moment.